Assalamualaikum to Dr. Hazwani. We are from Group 9 from Class 2-1, 1-2 and 1-1. We will present FBD, free body equations, free body diagram equations and calculations. The first presenter will be Nur Balkis from section 2-1, followed with Sirin Ruzahida from section 1-2. After that, Naim Aiman from section 2-1, Varan from section 1-1. Then the last ones will be Rushdan from section 1-2.
Hi, Assalamualaikum. Today I will present our assignment. I will introduce myself first. My name is Nur Balkis Japa and my matric number B0921104883. Our task for assignment is free body diagram representation from actual structure. Our project is to determine the free body diagram for a general structure, to create equation of equilibrium based on body diagram, to calculate moment and force our structure. For original structure, we have choose a man who is lifting weight. Free body. This is free body diagram. Our free body diagram. 70 degree at point C that represent the muscle angle of the boy. We assume dumbbell as G1 and the length of a boy hand is from point A to point B. For calculation, step 1, we need to calculate G1 and G2. As you can see, we got G1 is 24.525 Newton and G2 is 13.244 Newton. Next, step 2, we got FCD. For CD, 170.775, and step we got FY is FBY 122.707 Newton, and force BX is 58.408 Newton. Thank you.
Assalamualaikum and good day to Dr. Hazwani. My name is Siti Nurzahida binti Muhammad Idris from the MMV section 1-2. Today I will present our static assignment. It is FBD representation from actual structure. So, first of all, let's start with objective of the assignment. Firstly, the objective is to determine FBD from the original structure that we got from our friend. Secondly, to create equation of equilibrium EOE based on body diagram. Thirdly, the objective is to calculate moment and force in our structure. So let's see how our FBD looks like. Our original picture structure is a boy who lifts up a dumbbell. As we can see, the gravity that was on the dumbbell part G1 when the boy lifted it was 2.5 kg. Back to weight assumption, we have three assumption weight. They are 2.5 kg, 5 kg and 10 kg. I take 2.5 kg as my assumption weight. G2 is a force that we have discussed and studied where it was located along the boy's arm, so our G2 is 1.35 kg. Looking at our FBD, we give A to D as our force, and the distance of G1 to G2 is 100 mm. G2 to C is 130 mm and C to B is 60 mm. The angle is at between C and D. We assume 70 degrees should be okay. Now I will proceed with our calculation. After a thorough discussion, we give 3 steps of calculation in our FBD picture. Step 1, the G1 equals to 2.5 kg times with 980.1 Newton. We got from the 9.81 we got from gravity natural calculation, so equals 24.525 Newton. So G2 equals to 1.35 kilogram times with 9.81 gravity equals to 13.244 N by using calculator. The 1.35 was actually located along the buoy's arm at G2. In step 2, moment force of B is G1 multiplied with the distance from A to C, so it would be 24.525. Bracket with 100 mm plus 130 mm plus 60 mm bracket plus again with G2 bracket 13.244 Newton bracket 130 mm plus 60 mm bracket subtract with CD force sine 70 times with 60 mm equals to 7,112.25 millimeter Newton plus 2,516.3 nmm subtract with negative FCD 56.3 at 2 nmm. After that, we need to add 7,112.2 Newton millimeter and 2,560.36 Newton millimeter. So we got 9,628.61 equals to FCD 56.3 at 2 nmm. Don't forget to take out FCD and put it at the left because it needs to calculate with 9,628.61 divided with 56.382. So our FCD will be 170.775 nmm. Move to the step 3, which is the last step for this FBD calculation. The total Y force is 0. So let's proceed with the CD force times with sine 70 negative subtract with 24.525 Newton subtract with By equals to 0. We already have solved the FCD, so just times it with sine 70 subtract with 24.525 subtract 13.244 equals to By. Solve the By equals to 1,122.707 Newton. For the total X force is 0, negative Bx plus 170.775 times with cos 70 equals to 0, negative Bx plus 58.408 Newton equals to 0. So we will get our Bx equals to 58.408 Newton. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imam Birosli. My matriculated number is B0921104888. I'm from group 9 from class BMMV S2/1. Okay, I will explain about equation and calculation that we got from the original structure. Okay, firstly, create a FBD, free body diagram. Then we got assumption weight for G1 is 5 kg and for G2 is 1.35 kg. Okay, G1 represent as the loaded of the dumbbell and G2 represent load of muscle. Next, we calculate the force or weight of G1. Okay, 5 kg from G1 multiply 9.81 Newton, then we got 49.05 Newton. For G2, 1.35 kg multiply 9.81 Newton, then we got 13.244 Newton. Okay, next step 2, we find a moment at P point equal to 0. Then in the equation, 49.05 represent as G1 multiply the distance A to B point plus 13.244 Newton represent as G2 multiply the distance from G2 to B point, 130 mm plus 60 mm. Okay, minus FCD sin 17 degree, FCD sin 70 degree, multiply 60 mm. Then we got a final answer for FCD 296.919 Newton mm. Okay, lastly step 3, we find f false y equal to 0. Then in the equation FCD multiply sin 17 minus G1 minus G2 Newton minus By. By because the arrow is going down equal to 0. Lastly, final answer for By is 216.719 Newton. Okay, next for force at x equal to 0, negative bx, the arrow is going to left, then it means bx is negative, ft bx plus 216.719 cos 17 degree equal to 0. Lastly, we got final answer for bx equal to 74.122 Newton. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I will continue this presentation for this assignment. Before I start, let me introduce myself first. My name is Muhammad Rushdan Aiman bin Muhammad Rusli. My metric number is B092110563 and I from section BMMV S1/2. So next, for the objective is first to determine free body diagram from original structure. Second, to create equation of equilibrium EOE based on free body diagram. Third, to calculate moment and force for our structure. Next, for discussion. First, 70 degree at point C that represents the muscle angle of the boy. Second, we assume dumbbell as G1 and the length of a boy hand is from point A to point B. Next, for original structure. For G1 is the dumbbell, we assume three weight. First, 22.5 kilogram, and second 5 kilogram, and third 10 kilogram. So for G2 is angle of the muscle is 70 degree. So next, this is for free body diagram. Distance from G1 to G2 is 100 mm and G2 to C is 130 mm and C to B is 60 mm and for the angle is 70 degree. Next, for the calculation for weight 10 kilogram. For G1 I get 98.1 Newton, and then for G2 I get 13.244 Newton. So for find the FCD, we use MB equal to 0. So FCD I get 549.2065 Newton millimeter. So to find B1, I use total Fy equal to 0, so By I get 404.7413 Newton. For Bx, total Fx equal to 0, so I get 187.84 Newton. So That's all.
Good morning to Dr. Hazwani. I'm Isuran from section 1.1. I will be presenting about the calculation of this experiment. The weight of the dumbbell that I used to calculate was 2.5 kg. As for the first step, we calculated the force needed to bend the arm to pull up the dumbbell. So a total of 13.244 Newton is needed to pull up the 2.5 kg dumbbell. Next is the calculation of how much force needed to pull up the 2.5 kg dumbbell at the angle of 70 degree. The result of calculation showed we needed 170.775 Newton of force needed to pull up the dumbbell at 70 degree angle. Lastly is the calculation of the momentum of force acting on the person who is carrying the dumbbell. As shown in the poster and the calculation above, the force at y and x is equal, so the calculation is used to find out the moment of force acting on at x and y when carrying the dumbbell.